Hello, my name is Karthik, and me and Prithvi have chosen the TempleOS as our project. The Temple operating system is an operating system created by a company called Trivial Solutions. The company is the company is his brainchild. The man you see on your screen right now is Terry A. Davis. He is the founder and the sole employee of Trivial Solutions. Now, Terry has created the TempleOS single-handedly. He has coded it up right from scratch. He claims that God was directing him all along as he wrote the operating system. He is a schizophrenic. He's a bit of a madman, and the operating system is quite eccentric as well. It's very simple. It's kind of rudimentary, and it's an exercise in low-level programming. He claims it is a developer's operating system, and it's not meant for a commercial purpose. It doesn't have high-level graphics or uh, you know many security systems or anything like that. You're as close to the bare bones of the computer as you can get. Now, the operating system as such is quite lightweight. It's very simple. Some of the features of its simplicity are: one, it has a 16 color system. Now, this Terry claims was God. It was God who told him that the system needs to be 16 color. It is ring It is also ring 0, which means that there is no security involved between. I mean, you have access to pretty much everything in the system. You can interact directly with the hardware. A flat memory, which basically means no segmentation, and it is a 64-bit system, and it runs on an x86 instruction set. Okay, the reason now we chose the Temple operating system is because, well, no one really knows much about it. It doesn't even have its own Wikipedia page, and we believe as programmers, everyone should know something about this. This is a great achievement. Terry has written everything by himself right from scratch. He has his own compiler, which he calls Holy C. He has a couple of games in there. Admittedly not very good graphics, but that really isn't the point. There's a message which flashes on the screen as soon as you try to open a game, which says, "Don't play games, write them," which is in keeping with the spirit of the operating system, which is it is a developer's operating system. Um, the whole thing has around 100,000 lines of code, which is really not much, and it's after all, it's a very impressive achievement. Never mind the low level graphics, and the fact that it's quite hard to use if you're not a programmer and not well versed with writing, using the terminal and stuff. It's a big achievement, because writing an operating system from scratch in computer science is it's pretty much like building up a car all by yourself. So, well, that's it, and that's why we've chosen the TempleOS.
Hi, I'm Prithvi. Yeah. So the TempleOS was basically built by Terry A. Davis for recreational programming. His aim was to create something like the Commodore 64 for the modern day world. So what he did is he made a very simple structure for the operating system, and I'm going to give you a demo of the TempleOS on my virtual box. And so that should give you a flavor of what it's like and how simple the operating system is. Yep, so that's TempleOS that's started right now. Initially you can actually see, before TempleOS boots up, you can actually see a black screen, and it specifies the cores it's using to boot up the operating system. It asks me if I want to install a hard drive now. Yes. Onto a hard drive, no. And I can take a quick tour if I want. No, I don't want to do that. So this is the Temple operating system. This is the terminal where most of the work in the operating system is going to be done. This is a very rudimentary operating system. So you don't have any high level graphics, as Karthik pointed out. It is not aimed. He did not want this to be a commercial operating system. In fact, in one of his blog posts, he specifically contrasts this with Linux. With respect to this particular property of the operating system, it allows you to access any memory location in the computer that you want to. You can even edit the kernel programs, which is why it's a ring 0 operating system. So this is what makes it special. It's for recreational programming, so you can mess around with it. You can make a few games. So I'll show you a couple of features of the operating system. All these you see here are different terminals. So I can go to this terminal. If I hit Shift Escape, I close it. The term button down in the bottom right corner is basically the button to start off a terminal. So I can select a terminal. I'm at the command prompt, and maybe I'll check out the contents. Those are the contents of the home directory for my profile, and I can switch to let's say I switch to the root directory. Whoops. And it's not very good. Oh, there's an error. Let's see what's wrong with it. Oh, it worked the second time. So now I've switched to the root directory from home, and if I look at the contents of this directory, I see all the basic programs that the operating system uses. You would notice the bootloader program for the for booting the operating system, a compiler. You see the folder in which he has the programs for the kernel. You also see this folder called Adam. Now, this being a very holy operating system, Terry's called the initial program called program Adam. In Linux, it's called init, which loads up all the operating system subtasks. It's called Adam here. In fact, if you look up on top, you would see a marquee on top of each terminal. This terminal, the terminal which I'm working on, specifies dir, which is the process that I ran. If you look at the terminal on the right, you would see Adam task CPU number 0. So that is like init, which is PID 0 in Linux. It's called the Adam task in TempleOS. So as you see all the important files for the operating system all open. I can edit this whenever I want. So for example, if I want to edit let's say I want to edit adam.cpp.z. I directly get the program which Terry himself has written for starting up the operating system. In fact, you see the comments, it says this is executed by the Adam task at startup. If I scroll back, Adam task at boot. And then I can actually modify these files. I can move them around anywhere I want in the memory, and I can tinker around with the operating system. I can actually even write to specific ports of the hardware. So this really gives me a lot of freedom. Shift escape to exit. Now this terminal you see here is very special. It's not a scripted terminal. So there is no shell script, or there is no additional layer of an interpreter inside. What Terry has done is he's built his own programming language. As Karthik pointed out, this whole operating system is built right from scratch. So he's made his own compiler. It's called Holy C. Fitting in with the theme of the operating system, it's called Holy C. And if you notice, every command that I type in ends with a semicolon, just as they do in C. So you see dir ends with a semicolon, ed, which is edit, ends with a semicolon. That is because of this compiler that he wrote down. So every line that you write here is incrementally being fed into the Holy C compiler, and the program is being compiled line by line. You can actually write a whole function on the terminal and compile it directly. It will be compiled line by line. You notice here that adam.cpp.z here, it's a C++ program, but the .z file over here indicates something that's specific to TempleOS. .z means it's going to be automatically compressed whenever it's going to be stored, and it's going to be decompressed whenever you want to load it. Now I'm going to show you the menu that comes default with TempleOS. So you see rudimentary graphics versions here. It's 16 colored because apparently that's what God wanted Terry to do, and that's what the color should be as per God, as per what he says. So you see a lot of these games. Most of these games are not very playable. They're just fun little games. But then the one that Terry himself is most excited about, and he keeps highlighting in most of his videos, is After Egypt. This is a game called Frankenstein, in which you go forward and you have to shoot people who are dancing, and these purple people who are dancing around, and it really is a very pointless game, but it's a game all the same. And then I can select After Egypt, which really is one of the reasons why he's so excited about this operating system. And I don't know why my mouse isn't working. There you go. So this is After Egypt. This has a lot of biblical references, and it again is a pointless game, but it has a couple of interesting features to it. So you can look up Moses comics and something funny. Sorry, whatever. So he's done quite a lot of things which make no sense, but then they're there in the operating system all the same. You can talk with God. This is a very interesting feature. So oh God, the mouse, whatever. So that was the game. So there are quite a lot of these games. Most of these are pointless. He says the right games, don't play them, which is again one of the messages that he wants to convey. He wants this to be used as a programmer's operating system, not a user. So he wants people to tinker around at the lowest level, as close to the hardware as possible, and make good programs. So most of these features were games and fun little demonstrations that he's done. But one of the reasons why TempleOS is very unique is the way in which it treats all the processes. So what happens in Linux is everything in Linux is treated as a file. So even your terminal, which is standard output, is treated as a file. It's file descriptor 0. What happens in TempleOS is every process, every output, every place in which you can write an output or take an input is treated as a document. So you can edit the document and you can modify it. You can put in graphics whenever you like, however you like. So for example, this is the standard menu that Terry has written for us, which should not be editable. You should not be able to edit these things, but I can edit it all the same. I can edit it, I can modify it, I can select most of it, I can delete it. In fact, I'm deleting all the icons here, and these are not permanently deleted. So I can hit Control, and if I reload the menu, it comes back again. So I haven't lost anything, but I can treat any part of the operating system, any sort of interaction that I have with the operating system as a document, and I can edit it whenever I want. So that is one major advantage. So you can look up some of the videos that Terry has published on YouTube. He has a channel. There are about 100 tutorials. In one of the tutorials, he's actually drawn out a picture on inside a C program, and he's treated that picture as a variable. Not exactly a variable, but he's basically printed out the picture when the C program runs. So that's a really cool thing. You have a lot of flexibility when it comes to graphics, low-level graphics, a lot of default built-in functions. It's taken Terry 10 years to build this, but it's been worth it. He's made every single thing all by himself, right from scratch. So it's quite an achievement. It may seem as it's very low-level graphics given the high-quality graphics that we're used to these days, but then it actually is quite an achievement. He's used this data structure called Sprite, and there's this whole graphics library which is based on it, which he's used to save the vectors for the graphics, and that really is the heart of the various graphics programs and all these this animation you see here. And it's not just that he's built upon that. He's made himself this compiler for Holy C, the interpreter, the pseudo interpreter. He had a little exploration with just-in-time compilation in one of the editions. This was called Sparrow, by the way. This was called TempleOS. It had 3 or 4 different names before it came to TempleOS, and it's called TempleOS now. Yeah, so that's TempleOS. It's a really simple operating system. Very simple to, not too simple to operate, but if you're a programmer and you like tinkering about with operating systems, you like messing about with source codes, you should be pretty excited to see this. And I'm back at the terminal, and that was TempleOS. Thank you for watching.